Welcome to Understanding File Permissions. In this lesson, you'll learn how to read and interpret file permissions in Mac and Linux terminals. File permissions control who can read, write, or execute files and directories. We'll explore the rwx notation system, understand the three permission categories for user, group, and others, and learn how numeric permission codes work. Understanding permissions is essential for security and proper file management on Unix-like systems. File permissions are displayed using the rwx notation system. The R stands for read permission, which allows viewing the contents of a file or listing a directory. The W stands for write permission, which allows modifying a file or creating files in a directory. The X stands for execute permission, which allows running a file as a program or entering a directory. When you use ls-l to list files in long format, you'll see a string of 10 characters at the start of each line. The first character indicates the file type, such as dash for a regular file, or D for a directory. The next 9 characters represent permissions in 3 groups of 3. Each group shows read, write, and execute permissions. If a permission is granted, you see the letter R, W, or X. If a permission is denied, you see a dash. For example, rwxr-xr-x means the owner has read, write, and execute permissions. The group has read and execute permissions, and others have read and execute permissions. Understanding this notation is essential for reading and interpreting file permissions correctly. You can see these permissions change when you modify them using commands like chmod, which we'll explore in more detail later in this lesson. The 9 permission characters are divided into 3 groups of 3, representing 3 different categories. The first group of 3 characters represents permissions for the file owner, also called the user. The owner is the user who created the file. The second group of 3 characters represents permissions for the group. A group is a collection of users who share the same permissions. The third group of 3 characters represents permissions for others, which means everyone else who is not the owner and not in the group. This 3-tier system allows fine-grained control over who can access files. For example, you might want only the owner to write to a file, but allow everyone to read it. Or you might want only the owner and group to execute a script, but prevent others from running it. Understanding these 3 categories is fundamental to managing file security on Unix-like systems. Permissions can also be represented using numeric codes, which is often more convenient than the rwx notation. Each permission type has a numeric value. Read is 4, write is 2, and execute is 1. To calculate the numeric permission for a group, you add up the values of the permissions that are granted. For example, read plus write equals 6, read plus execute equals 5, and read plus write plus execute equals 7. The numeric permission code consists of 3 digits, 1 for each category: user, group, and others. For example, 755 means the user has read, write, and execute permissions, which equals 7. The group has read and execute permissions, which equals 5. And others have read and execute permissions, which also equals 5. Common permission codes include 755 for executable files, which allows the owner to read, write, and execute, while group and others can only read and execute. Another common code is 644 for regular files, which allows the owner to read and write, while group and others can only read. The chmod command uses these numeric codes to set permissions, like chmod 755, followed by the file name. Excellent work! You now understand how to read file permissions using rwx notation, recognize the 3 permission categories for user, group, and others, and use numeric permission codes like 755 and 644. These concepts are fundamental to file security and management on Mac and Linux systems. Practice reading permissions with ls-l and experiment with different permission combinations.